Good morning, everyone. Thank you for joining us. My name is Tony Ogavin. I'm Director of Client Services at Markforged. And today we're going to be exploring how manufacturers are bringing additive and subtractive technologies together to work more efficiently to produce better parts and better processes. Quite often conversations around these two methods seems to be either or, but really we like to think about them as complementary methods. So we're joined today by Phillips Corporation's own John Harrison, Director of Global Additive, and Markforged co-founder and CTO David Benheim. So these two gentlemen will be sharing with us their insights on these topics and discussing the benefits of additive adoption, how to implement it into traditional manufacturing environments, and what the future holds for modern manufacturing. So with that, I'm going to let John and David introduce themselves, and then we can dive right in.
John, you want to start?
Yeah, David, please.
Okay, I'll start. I'm David Benheim. I am co-founder and CTO at Markforged. I started life as a mechanical engineer, working in the machine shop at my high school. Did BattleBots for a period of time. Cut my teeth, on a drill press and a Bridgeport mill before going off to college and eventually transitioning into software engineering. I met my co-founder Greg while I was at school, and as soon as I graduated, we started Markforged together. Built the Markforged platform, and here we all are, 8.5 years later.
I'm John Harrison. I'm from Phillips Corporation. Worked with Phillips for 11 years, and we provide manufacturing solutions, whether they're additive or CNC, to the manufacturing community, commercially, federally, and globally.
Great, thank you. So let's just start off with a little bit more history about your roles and how we all got here today. So David, tell us a little bit about, when you and Greg came together to form Markforged, what was your long-term goal and what were the issues that you were trying to solve for? What was the catalyst that helped kick off the company?
Yeah, so just for background, and this story is a little bit easier to tell when I explain, how Greg and I met, kind of heading in different directions. So Greg was an aerospace engineer at MIT, who then became a serial entrepreneur, phenomenal mechanical engineer, built a ton of different things. Before Markforged, he was making robotic controlled race car wings for Ferraris and other track cars, and had a couple of other companies along the way. And I was a software engineer who at the time was working remotely for Palantir and was just about to finish my MIT computer science degree. And I had a fair amount of robotics and manufacturing experience at MIT, but had never actually worked professionally in the manufacturing sector. But I had all these ideas that I had kind of absorbed from kind of the Silicon Valley ethos at MIT about how software could be built and what problems it can solve the industry. And so Greg and I met, and I was just telling John before the webinar started that when I showed up at MIT, the first thing I did was went to every single machine shop on campus and signed up to get trained, met the local shop people, went through training, got access, because that was the background I came from, and I loved to make things. And through my entire time at MIT, I had access to water jets, and this is 2009, 2010, access to water jets, manual mills, manual lathes, CNC, lathes, mills, and a couple of other kind of exotic manufacturing equipment, but no 3D printers. There were no 3D printers I could find on campus. And so for me to make things out of hardware was still an arduous process, right? I had access to CAD, but on the software side, I had access to kind of unlimited resources. I had the cloud, I had a bunch of other MIT kind of resources. MIT owned the 18 block of the IP space, right? So I kind of had infinite web power there, which is super cool. And so when Greg and I met, Greg's like, hey, I know how to 3D print things out of carbon fiber. What can we do with this? And we brainstormed for a little bit and basically figured out that what we had in front of us was an accessible way to make industrial strength parts, right? And the reason I say accessible is because we were able to package that 3D printing of carbon fiber technology in a super easy to use box that we then wrapped with a kind of best in class software experience that takes a lot of the kind of expertise and tribal knowledge out of the equipment, out of a maybe technician's or expert's brain, and puts it into the product so that anybody can use it. And this box will sit on your desk, and you can put a CAD design or a 3D scan into the technology, and then out the other side comes an industrial strength part. And in that process, you don't have to stand next to the machine with your hand on the e-stop, right? You can go back to doing what you do best, which is design or solve other problems. And so we envisioned this from the beginning, like, hey, we can do this with carbon fiber. And then eventually we figured out how to do it with metal. And that's what we brought to the floor. But again, it was that I as a mechanical engineer turned software engineer, and Greg as a aerospace mechanical engineer who had been building hardware technology for a long time, understood that like, to actually get a physical part, it can be kind of arduous, right? It can take you a little bit longer than I can, to write code and deploy something. So we wanted manufacturing to be as simple as, like, you can design it, you can make it, right? Or it can be made for you in a desktop box. And so this was a catalyst that kicked off Markforged, and the ball started rolling, started snowballing. And we did the Mark 1, we did the Mark 2, we did the X7, and progressively, as we've gone down the line, up until the Metal X and some of our future technology that will come out later, the machines have gotten significantly smarter. There's more sensors, and that smarts actually makes them easier to use. The machines are more self-aware of their current state, their current situation, their calibration, things like that. And the software on the design side, on the prep side, actually makes it a lot easier for you to take any arbitrary part that maybe not isn't even designed for additive, and bring it into the software, and then prep it for print, and then send it through the machine. And the machine is super easy to use. In fact, to run a Metal X and to run a composite X7, it's basically the same maintenance cycle. Same user interface. And in fact, you can see them kind of behind John back in the distance. The machines look very similar because they're based on the same kind of print engine spinal cord. And so again, the goal was to solve this accessible industrial strength parts. And we imagined this technology living side by side, with other manufacturing technologies to complement them, to form kind of a symphony of manufacturing capabilities on all kinds of factory floors, whether it be in a job shop, or in an R&D lab, or on a forward deploy base on the edge, what I would call it edge manufacturing, distributed manufacturing, in places where you can't airdrop a CNC or injection mold or something like that. And so that's where we started, and we're going to hear a little bit more about today where we are. But yeah.
Great, thank you. And so, John, with the experience that Phillips has in traditional CNC machining, more than 60 years, and nearly 2 decades in additive, talk to us a little bit about how, given the background that David provided us with, how Markforged has provided this more accessible platform for manufacturing parts in the context of these more traditional processes. How do you see additive fitting into the traditional machine shop? And do you ever see additive potentially even overtaking some of these traditional methods like CNC?
Really interesting question, Tony. And basically from where we've come from as a leading provider of CNC technology for 60 years, it's tough for me to imagine that additive is ever going to take over CNC manufacturing, just because the process is always going to dictate. So in my mind, when I think about a CNC machine tool and whether additive could replace it, I think of a shaft, right? So how a lathe works, turning a shaft, I can't think of a better way to make that part than on a lathe, or drill and tap a hole in a machining center. And our company continues to provide the right solutions, but it has to be dictated by the economy of manufacturing of the part. So I think, when you look at additive, and it's a big part of our future plans, it has to be important that the right solution is applied to our customers' needs in order for it to get adopted. I'll give you a story. 7 years ago, I started restoring a 1967 Bronco, and I broke some old brake clips on it. They're little metal clips. And I went to the local Ford parts supply store looking for 1967 brake clips. And the guy behind the counter pulls out a Ziploc bag, and I recognized that they were plastic and they were 3D printed. So I started asking questions. I'm like, where are you getting these 3D printed brake clips for a 1967 Bronco? And he told me that he gets them from an Amish guy in the middle of Pennsylvania who reverse engineers old parts that you can't find and 3D prints them. And at that point, I think I started recognizing that, additive might become a little more mainstream. And, with our relationship with the DoD, we've seen some very sophisticated applications for additive manufacturing. Powder bed printers produce rocket engines and flight critical parts. But the challenge, I think, when you start considering adoption of additive might have been that price point in the beginning, and recognizing what parts were economically viable to be created on $1 million printer or $2 million printer. Looking at the part to my right is a rocket engine. It's printed on an EOS machine from an assembly, and it replaced a traditional assembly and a machining process because it was more economically viable and the part was better. But it's tough to consider as a job shop being accessible to go out and find this part. What I think Markforged has been able to bring to the traditional machine shop is a more approachable tool that's industrial. So yeah, they could go out and buy a consumer level 3D printer and maybe print a prototype of something, but they couldn't really get a usable part. If you're able to introduce a Markforged printer, which has carbon fiber backed materials that are a little tougher, the opportunity opens up for them to start using stuff within their own shop, like soft jaws or fixtures or drill guides. And then once they start utilizing that, they'll start recognizing the value of the technology in direct manufactured parts. And I told David earlier, behind us, we're integrating into a Haas machine, a wire-fed direct energy deposition printer for the Navy. So it's sort of a hybrid technology. And our guy that's integrating that had to build a cable guide last night. And originally his thought was to go towards manufacturing that out of a block of aluminum. He was going to go get a block, look to find the tools to mill it and try to figure out how to do this. And then he turns to the other side of the shop where we have a couple Markforged printers set up. And he goes, why don't I just print that? I already have the design file for it. So last night he presses the button, and right now it's about set to come off these cable guides that he's going to install as a direct replacement for this originally thought of aluminum part for a machine. So I think that's the promise that if we introduce this technology to the machine shops of the community, because of the value, because of how easy it is to use, and because of the properties of the material, the adoption of additive in machine shops is going to happen very quickly.
Great. And so David, talk to us a little bit more about the Digital Forge, Markforged Digital Forge, and how it's a differentiator in the additive space. We know that the printers themselves can, alleviate some of the economics and time associated with traditional manufacturing, but what is it about the platform holistically that sets it apart?
Actually, so before I dive into this, I want to kind of tag on to what John was saying, right? So again, I got my start in the machine shop back in high school, making these parts for robots. My first job ever on the team was to drill holes in steel. And so every day after school at 3 p.m., I would show up to the machine shop and I would start with a very small drill bit and then peck on up to a larger one over and over again, 6 hours a day, 5 days a week. And I started as a freshman. Sophomore year, I'm starting to design things and make them, I'm getting a little bit more dangerous, a little bit more. Eventually I learned how to use the mill. And as I'm learning to use the mill, I'm not just drilling holes anymore. I'm actually machining things. It's a little more complicated. And again, this is very basic stuff, but as a 14-year-old, 15-year-old who's learning, who had taken for granted everything that he had ever owned and had how complicated it was to manufacture and make, especially in the age of Amazon, where you go online, you order something, it shows up at your doorstep. Like I had no idea how this stuff was made. Now that I'm trying to make things, like, holy crap, this is actually really hard, right? You have to, the concept of fixturing something was like totally mind blowing to me. And then the idea of actually being precise when machining something or accurate, like, moving this handle on a bridge port and then reading the dial out, getting my micrometer out, like calipers, and then figuring out what power levels were for the first time, right? And I went and made a robot kind of carelessly and then went to assemble it and it couldn't go together. And I realized that all the time that I had spent on the machine being a little sloppy didn't pay off. And so I understood the pains of how much craftsmanship and expertise went into making these basically pretty basic parts that I had designed. I was still also a noob at CAD. And so then, going to see professional job shops, there's a CNC distributor in my hometown of Sudbury who actually was helping us make some of these more complicated parts. And I remember the first time going into that job shop and just seeing how complicated some of the parts that they were manufacturing for real customers in the real world, and just my mind being blown, right? Like I had made these really simple parts and had done so really poorly with a lot of effort. And then seeing these parts that were about to go into race cars or, other robots or other CNC machines or things like that. And just being like, how the heck did you hold that? How the heck did you make this, right? And then actually, when I was talking to the machinists there who were supposed to make these robot parts for us, they're totally volunteer. Thank you so much, Methods Machines. But they had a line. They had a queue of jobs, of parts. These were some of the busiest people I had ever met in my life up to this point. And so, when John's talking about this complement of additive and subtractive living together cohesively in the same environment, his example is you could print this part that you otherwise would have machined, right? You start hacking it that way, but you also can use the machine to kind of complement. So a 3D printer, especially a Markforged machine, living next to your CNC machine can take that queue and help you eat through it faster, right? You can either help print the fixtures to machine some of these parts, or you can take parts out of that queue and potentially print them, right? And so you can actually start working through this job backlog much faster. And it took me kind of 6-7 years later to kind of realize that, okay, well, 3D printers are actually a thing, and holy crap, now I can make industrial strength parts in these 3D printers. And then you could actually feed that back into the old, I wouldn't say old, but the traditional way of making things, right? And actually accelerate this process. It's a symposium of different superpowers, right? Which leads us to the Digital Forge. Right, so the Digital Forge is the comprehensive name we have for the Markforged platform. It is the combination of best-in-class mechanical engineering on the hardware side, the material suite that we offer, and the software. And the way I describe the Markforged engineering team that produces this platform is the Avengers of engineering, right? And if you think about the Avengers, you have a bunch of different superpowers that on their own make for some really cool movies, but when combined, they become more powerful. The sum is greater than the whole, right? And that's the case for additive and subtractive, right? And so in the case of the Digital Forge, you have this really Gucci piece of hardware. If you've ever seen a Markforged machine, open it up, take a look at how it's built, because I'm very impressed. The mechanical engineers we have are phenomenal. But it's also complemented by the software suite, right? And so again, a lot of the ideas that I brought from software engineering to mechanical engineering, to manufacturing engineering, to make life easier, right? You go to work or in your personal life, you have your iPhone, right? Amazing software, right? You have Google, it's free, it's amazing software. You have Facebook, that's pretty solid software as well. And then sometimes in your professional life, you're using software that's kind of clunky, kind of slow, right? I'm a huge fan of CAD software. That's pretty nice. But other things like the Bloomberg terminal, or even stuff you see at the doctor's office that healthcare is run on, critical infrastructure looks kind of clunky. And so we imagined a world where you could have best-in-class software that helps you control this kind of sci-fi piece of technology that then sits next to, technology that I described earlier today to John as almost perfect, the subtractive methods, right? That can then become, the Avengers of manufacturing, where you have this superpower of subtractive that we've, and then you have this superpower of additive tied together with this software solution. And that's that's the Digital Forge in the wild, right? And the reason it's a differentiator, and this is the description I'll use, is that most other folks in the industry are hardware companies that tack software on as an afterthought. And that's actually the recipe for getting this kind of subpar, non kind of what I would call consumer grade like software, professional grade software. Markforged is a software company that happens to produce, best-in-class materials and hardware that is tied together in this Digital Forge platform, right? It's why we call it the Digital Forge. We don't call it the Carbon Forge. We don't call it the Metal Forge. We call it the Markforged Digital Forge, right? Because it's coming together, and you spend almost all of your time interacting with the technology through the software. You design your part in CAD, you bring it over into Eiger, our software platform, you hit print, you can watch it, you can watch it print from home, and then you get an email and you go show up to the part, like, someone's going to come up behind John and grab the part off the bed, and there it is, right? And in fact, like in the future, as CAD and CAM and generative design and the CNC machines get smarter, it'll be the exact same experience for subtractive as well. In fact, like you'll take a step back and you'll say, software, I want this part to get designed. It'll design the fixtures and the tool pathing for the machine, print them both together, and then you'll load it up in the CNC, and then it'll do the rest for you, right? And that'll be a digital forge that's expanded beyond just additive.
Great, thank you for that. So John, given all of this context we've just spoken about how these two methods can come together in the machine shop, are there any industries or applications specifically where you see additive or the partnership between additive and subtractive being the most disruptive in a good way, the most beneficial? Who can really take advantage of this?
Yeah, so I think it's a really interesting question, and it's fun to be part of this industrial revolution that's going on. Everybody calls it the fourth industrial revolution of digitization of everything and artificial intelligence and robotics and the like. And I am a little nostalgic for some of the things that we've lost because of it. And a great example is Blockbuster. I love Blockbuster. When I was growing up, going into the store and getting to pick out this new release video and seeing the whole wall, hoping the movie you wanted was in stock. But flash forward to Netflix, and it's way better. You have a digital access to any movie that you could possibly want almost instantaneously, on demand, without going out. So you've really displaced what Blockbuster delivered, but you've improved on it. And to me, the opportunity that's transforming is the easiest one is prototyping, right? I have a cousin that is in college right now, and he's in his lecture hall on that little desk that you're used to, and he has his laptop there, but he needs to charge his phone and access it. He didn't have a cable and didn't have enough space, so he said, maybe I should design some type of fixture that attaches to my laptop so I can connect my phone and charge it. So he and his buddy went in, designed something, and called me and said, hey, I know you're in 3D printing, can you print this? So a week later, we print a prototype. He re-engineers it one more time because he didn't like something. So he has a functional part in 2 weeks. He applied for a patent, and because of the way the digital economy goes, he's kickstarting that business based on an additive part. I think that the speed of innovation is what's going to change. But two other, I guess, industries that I would look at is MRO industry. And, coming from Phillips supports the DoD since World War II. And maintenance and repair is so important to the DoD in maintaining readiness of equipment for our warfighter. So think about, if your soldier's in the battlefield and that tank or that vehicle isn't in service because of a part, somehow you have to get a replacement part. And it could be in an inventory in some other part of the world. It could not be available for a while, and you've basically taken that asset out of the fight. To introduce a way to digitally inventory all these parts and then send it to the point of need and have a printer make that is the ultimate maintenance and repair operation game changer. And while I talk about a story in DoD, commercial is doing this as well. David, your company has a great example with Frito-Lay, where you have manufacturing production lines that are implementing printers to support their production lines when something goes out of service. And if they're able to produce that part at time of need, then the production line keeps going and profits soar. I would offer one other industry that is exploring the benefits of additive manufacturing, and that's logistics. We all know that FedEx has invested heavily in additive manufacturing to try to figure it out for this very reason that, if you have the ability to replace all the airplanes and trucks that deliver a part from one component to the other with a digital conduit, that is the next level of logistics. And the best example of that is the space station. Getting components into space right now is very expensive. So NASA decided that they wanted to put a 3D printer on the space station so they could digitally send files up and avoid the time and cost it takes to move something from one place to the other. That's the promise of industries that could get disrupted in the near future.
Mhm. David, I'd love for you to answer this question as well. But before you do, I just want to call out to the audience that if you have any questions about what we're discussing or anything, it's specific that you would like John or David to comment on, please feel free to add those to the Q&A chat, and we can get to them toward the end of the conversation. So David, any other hunches on, disruptive opportunities, industries, and applications that can really benefit from this technology?
Look, I think John hit the nail on the head with this one. MRO, logistics, point of need applications. Additive manufacturing is a new tool on manufacturing's tool belt, right? And we've seen it go through a kind of journey and maturation phase in the last 40 years from invention to now, ranging in new technologies emerging, new ways of making things. And it's jostled a little bit with kind of other technologies, but now it's starting to find its home and its niche. And really, if you take a step back from some of the things that John mentioned, like it's a flexibility, right? It is a new way of solving problems that we've already had, that we've solved other ways before. And to his point earlier about economic elements, like it's cheaper in some situations and more expensive in others, right? So would you, would a 3D printer compete with injection mold right now? No, probably not, right? And so you wouldn't use this problem for that, right? One of the lessons I learned very early on in the machine shop was always use the right tool for the right thing, right? That flathead screwdriver is not some kind of wedge thing, right? It's a flathead screwdriver. Use it. Go get the chisel or something else for what you need it, right? Same thing with additive manufacturing, right? You wouldn't use this to try to mass produce something, at least right now, right? Maybe sometime in the future, but would you use it to reduce inventory, right? Inventory footprint, whether it's for tooling or for things that you might need to produce on site, right? Would you use it for MRO? Absolutely. Would you use it for a logistics play? No, yeah, no question. And we will start to see more and more of these applications. This is actually the best part about working at the company, is seeing and talking to customers and seeing how they leverage the technology to solve new things. I am continuously excited by and blown away by kind of customer ingenuity and how creative they get with the solution, both with additive and with subtractive, and how the two come together. I think I think yeah, I mean, I think John said it right. Yeah.
Great. So, I think the point you made around this is a new tool in the tool belt, and knowing when to use it, what a specific tool and why, are really good points and very relatable. Wondering if you both can comment on maybe why an engineer may be skeptical that this tool belongs on their tool belt, if they are unsure if it is the right tool for the job. Are there things that are holding the industry and individuals back from buying into adding this to the tool belt and picking it up and using it, and why?
Tony, is it okay if I take this one, David, to start?
Please. Yeah.
So, it's something to be said that what's holding additive back, but in reality, additive is not being held back. It's probably one of the fastest growing industries out there, and all projections are exponential growth in the adoption of additive across a number of different platforms. If I was to suggest that something could change to accelerate that, it's probably education. So, when you're a traditional machinist or whatever industry you have, I'll go with machining, you have certain things trained in you and mindsets and tribal knowledge of manufacturing. And I grabbed a part. This is a traditional machine part, right? So if you walk up to a machinist, the first thing they're going to do is grab the part as if they're going to fixture it in their machining center. How they're going to hold it first. And if the part has, in this case, something on the bottom, they recognize that they're going to have to hold it first, machine it, and flip it, and machine the backside. The second thing they're going to do is they're going to take their finger and act like it's the spindle on a machining center and figure out how they're going to make the part in a tool path, and whether they have to index it and what tools they need. It's a mind shift, though, when you start thinking about additive and introducing this concept that you don't need to think about fixturing. You don't necessarily need to think about tooling. You probably just need to think about how you're going to orient the part, this way or this way, if you have the material in stock and if you have access to the printer at that point. So my feeling is, as we are able to educate traditional machinists about the capability of this, they're going to drive the solution and they're going to drive the adoption of the product. It's our job to expose it, the thought process of manufacturing additively to them, and give, as David would say, another tool in their tool belt.
Great. Yeah, great. Thank you for taking that first. Great response, John. I think, to complement what John said, I think look, like all technologies that come out, there's like a hype cycle, right? And additive has its hype cycle. We saw like a bunch of hype in the mid 2000s. We saw some hype before that. AI has gone through the exact same thing. In the 80s, like everyone was starting AI companies. They thought Lisp was going to be the next big thing, and then nothing came of it, right? And here we are 40 years later with another kind of resurgence, renaissance of AI. Same thing's happening with additive, right? And really, after this hype cycle kind of burst, there were some promises that were made that maybe were failed to deliver on. There was some hype that was built around those promises. When we started in 2013, it was kind of on the tail end of that hype cycle kind of losing its last breath. And Greg and I were like, okay, again, accessible industrial strength parts. This is the most important problem that we can solve in manufacturing, or that we are able to solve. And that actually is what needs to be promised. And so as we've seen the last 10 years, we've seen a renaissance of additive, to John's point. It is one of the fastest growing technology adoptions in manufacturing today, right? It's changing the way people think about making things, it's changing the way people make things, it's changing like the way traditional manufacturing is being used today as well, right? And so, we're as a business, and John and our customers, we are learning how to use this new tool, and we are paying kind of off some of the hype. And again, if you go back in time 15, 20 years and you ask somebody, what would you 3D print? They might say some crazy things, right? But today, if you ask people what they're going to 3D print, they're like, oh, I might print some tooling, I might print a robotic end effector, I might print, a replacement part for something, I might print a service part for something, I might print a part that I don't have the tooling for anymore, right? They have a bunch of new practical applications, right? I mentioned this to John before before the call, but like when the iPhone first came out, the first 100 apps in the App Store were kind of silly, right? There was like a beer drinking app that used the accelerometer, like that was kind of cool. And there were some cool games. But then people eventually figured out like, oh, it'd be great if I could order a car from my phone, or if I could send a silly picture that turns my face into a cat, right? Like people learn, or I could send money, or I can buy stocks, or I can do all these other things, right? And people learned how to use this technology and adapt it, right? It went over the hype cycle. Additive is over the hype cycle and heading into the golden age of like changing manufacturing, right? We are just getting started for how this technology is going to change and scale things.
So can I add to that, David? We've been in the additive business for 15 years, and the one key thing that is a real parallel is that first 100 days, and making sure that the technology and the capabilities of the technology are implemented in those first 100 days. And what I mean by that is, you could get a printer tomorrow and probably print a few things, but if you don't unlock the full potential in the beginning of that first 100 days, you might not introduce that into your tool belt and introduce that into your solution profile. So what Phillips has done, and we are a solutions provider supporting these innovators that are creating these new ideas and solutions out there, is that we've invested in applications engineers to be there and to proactively be there in those first 100 days to make sure that the end user understands all the variables and all the advantages of the technology. If they stumble on a roadblock, we're there to help them and teach them, to get them to that point where all of a sudden, like I shared about Brian making that cable routing bracket, that the aha moment comes on and they're ready to fly.
So I'm actually going to bring in a question from the audience because it's a really great question, and I think it's very relevant to what we've discussed just now around how to know how to use additive and just, really starting to bring it into the forefront, or like you said, David, the golden age. But the question is, what skills should an individual have or acquire, if they're going to pursue additive, whether it's a career dedicated in additive, or if they want to, be a leader within their organization and, helping to change that mindset? What skills do we think are really critical for an engineer to have to be a leader in additive?
You wanna go first, Dave? I spoke last.
Yeah, so look, we see Markforged, we see a ton of folks applying to jobs at the company. We're hiring like crazy right now. So if you're interested in working on additive technology, throw your hat in the ring. But as far as skills go, I mean, it's still the same stuff that it was, before additive 20 years ago. It's good design principles. Additive is, again, a tool in your tool belt. So you have to learn what the pros and cons of the technology are. And additive is not just one technology. It's a bunch. It's a broad class for a number of technologies. And John mentioned direct energy deposition. There's Markforged technology, which ranges from plastic parts to continuous fiber reinforced parts up to metal parts, and a bunch of different types of metals, and you have to understand the different material properties for those metals. And again, these are all different tools that you're using to solve, different problems, right? And so same thing, you have to learn about subtractive manufacturing or injection molding, or assembly or drawings or any of that stuff. It's like the whole tool chain, right? So it really depends on what problem you're trying to solve and what you want to do for a job. If you want to work on 3D printers, at Markforged, we've got a team of materials engineers, software engineers, electrical engineers, firmware engineers, application engineers. These are folks who take the technology and figure out how to solve problems with it, how to complement existing technologies. They're basically experts, right? And the way they do that is, one, a long history of making things, right? If you're not making things on your weekends, if you're not, if your hobby isn't to just jam out and make stuff. John mentioned earlier that he was like restoring a car. Like, I made a bunch of robots. I still hack on things. At home, I've got a 3D printer and a little desktop PCB mill that I'm making stuff with. The more stuff you make, the more you understand better ways to make things, and the more you'll understand how to solve like those problems with different technologies, right? Eventually you'll get to a dead end and you'll need to have a new solution to that, right? So aside from just being a really phenomenal engineer, and the skills that come with it, make stuff. That's what I would say.
Wow, I couldn't agree more with that. One of the things that I think, Phillips has seen, and we're involved with through our H-Tech programs with Haas, the training of the technical workforce in machining is that curiosity, right? But when you start considering where digital manufacturing is going, it helps that the next generation is already used to understanding technology and used to being able to push buttons to make things work. And I see this digital manufacturing revolution transforming what the workforce looks like a little bit. Okay. For me to walk up to a machining center when I first got it and be able to produce a part off of it or get it to run again was probably a challenge 10 years ago. We unboxed the X7 the other day, and the part process paused for some reason. I had a client coming in and I'm like, I wish that printer was really going to print. So I called my technical guy. He wasn't around. So I just looked at it, and the design of the Markforged machine is so intuitive that I was able to figure that out. And I think that's where the knowledge base is going, to digital manufacturing and understanding software, understanding electronics. And if you're going to get into additive manufacturing, a strong software and digital base is good. That general curiosity on how things work, though, is always going to benefit you.
And so, John, just, to further that point, you've been working to introduce this technology into machine shops for the last 15 years. What about the culture of those machine shops, the mindset of the individuals, have stood out to you that say, okay, this is a team of engineers who's going to take additive and really, it's going to take off and it's going to revolutionize their business? What about those teams do you feel are maybe different from those that are slightly more hesitant to adopt additive?
So, in my opinion, in my experience with machine shops or fabrication shops or job shops, is that they're the innovators, and they constantly have to reinvent themselves. Okay, OEMs, their job is to have a product and reduce the cost and maybe introduce a new product. But you look at a job shop and they have to take whatever's coming in, whatever's available, compete with the world market to try to reduce costs, find a better way than the job shop down the street's going to do it, and continue to improve and evolve. And that entrepreneurial and learning mentality is, I think, what's going to drive machine shops to gravitate towards the best technologies. So if they're exposed to, again, this tool belt kind of mentality, this new tool in their arsenal, they're going to be able to adopt it and recognize the value of it, as long as we're able to sort of expose them to it in the correct way.
Mm-hmm.
Now, most job shops are operating in a lower volume, low volume, low price, creating more value for their end users. And that's where I think some of the benefits are going to become very apparent with additive. If you're making hundreds of thousands of something like many OEMs are versus making 10, the decision to jump to additive is easier. And then you can start getting exposed to what's possible with additive, and then start changing part designs and helping your customers reduce inventory because you can produce parts quicker and you don't have to wait for tooling and the like. Does that make sense, Tony?
Perfect sense. Yes, thank you. So I want to shift gears just a little bit here and go back to something that David had touched on earlier around the hype cycle and how we're seeing similarities between the hype cycle of additive with AI. Markforged has recently incorporated AI into the digital forge with our blacksmith capabilities. And so, David, just want to hear from you a little bit about how you think that can improve and influence the future of additive, and what, where you see this combination of the two technologies, additive and AI, how that's going to grow and change over the next 10, 20 years.
So two pieces here. One is a product design philosophy, and the other is an emerging trend in Factory 4.0. So the design philosophy behind everything that I build, everything Greg built, what Markforged does as a company, is this idea that humans, are innately gifted by the universe with this kind of creative thought, this ingenuity, this vision, and robots and software right now are not, but they're really, really, really good at math and doing repetitive things, right? And so this philosophy that humans should do human things and robots should do robot things, or software should do software things, really drives like the best product design in the world, right? Any place where a human, is doing things that software or robots should be doing is a misuse of that human's potential, right? And so the world together will grow, and our economy will expand, our lives will change as more people who are doing robot things are free to do creative human things, right? And if you think about the opportunity for AI, it's a step in to start freeing humans from doing a lot of those manual or math or software things, software as well, right? If you think about like robots picking things up and putting them in boxes, like, it can be really tough for robots to grab things because they're just not as smart as humans. Like humans have millions of years of like fingers and grabbing things, picking them up. We know how heavy things are. We know we can estimate their moment of inertia. We know how to move them around. We know how not to squeeze them or crush them. We know not to hit things. But as robots learn this over time, humans don't have to do that anymore. They can go fix other things, right? This is actually the fundamentals of society. On the other side is data, right? This emerging trend in Factory 4.0. All of these machines in the factory that were previously silos, weren't connected to anything, weren't pumping out data, are going to start to come online. And things that we weren't measuring before, we have this kind of statement in software: measure everything, record everything, log everything, right? Like, my software engineers are always asking, okay, like, where can we store this information? Because at this point in time, storage is essentially free, right? Think about the CNC machine, for example. Like any sensor, any servo, any like widget, whenever any event that you have in the machine, lube on, lube off, coolant on, coolant off, head position here, record all of those things, right? Current being drawn by servos, right? Like rotations, different speeds, things like this, like forces on the head, record all of that, put it in a database somewhere. And eventually, AI will come back and it'll look at those things and it'll start to correlate different events. Oh, okay, this tool wore down over time when these signals happen, or this servo was like, this servo actually failed, we had to replace it. Oh, these are the signals that led to that, right? Humans right now are either reactive to these things or are waiting, right? And so Blacksmith, starting with Markforged, we're fixing a bunch of issues with the part and with the machines, right? There's two sources, and we have a bunch of questions about how our metal technology works. So I'll kind of address that in the statement. But there's kind of two sources of issues with manufacturing in general. There's machine to machine variance. we're dealing, in software you deal with bits, in hardware you deal with physical atoms. We're fighting physics here, right? And physics is a cruel mistress. So in this case, like no two pieces of hardware are exactly the same, and no two output of them are exactly the same. Is why we measure things. Machine to machine variation, and then the other side is process variation, right? So everything you make something with has some quirks to the manufacturing method that you as an engineer need to know and need to account for in your design process or in your tuning of that system, right? Markforged is slapping a bunch of sensors on our technology and actually 3D scanning the parts as they're being produced on our printer so that the software can have a mental image of both its body, the 3D printer, and the part that it's producing, closing the loop on what it's building, right? All that data is being fed, again, instead of having data silos, it's being fed back to one place where we're chewing on that information. And we'll be producing AI software solutions that actually, again, free humans up from actually having to solve those problems themselves, right? You won't have to tweak your machine, right? We've had some crazy stories in the past where a bearing went bad on a machine. This happens, right? You know, hardware wears out. It's just what it is, right? A bearing went bad, and instead of printing perfect circles, it was printing an oval, right? And so the engineer went back to CAD and actually squished that oval back into a circle, or sorry, expanded their, they squished it the other way, right? They compensated. CAD's not really designed for that, but they did it anyways. And so then their machine printed perfect circles, even though it had a bad bearing. These are things that the machine should be self-aware of and should actually flag for you or fix itself, right? And, you know, if you've got a machine in a machine shop in Cupertino, California, or in Watertown, Massachusetts, or in Brazil, those machines should produce the same parts within some tolerance without having to have a human tweak those things, right? Humans are better off designing parts or solving more complicated problems than they are tweaking these little things. And so AI will actually unlock that potential over time. And on the metal side for Markforged, if you don't know, so it starts with, we print the slurry. The slurry is made up of metal powder, a plastic, and a wax. It's very similar to metal injection molding. It's a custom material that we've designed. We print it out FDM style, and you get your part out of the machine. The part's a little bit like clay. It's brittle. You could break it if you wanted to. It's not quite metal yet. It's full of metal, but it's not quite metal. You put it through a wash. This is a solvent bath. What that wash does is it diffuses out the wax. So what you're left with is just the metal powder and the plastic. And then you take that, you put it in a sintering oven. The word sinter means to take a powder and melt it into a solid, right? In fact, DMLS, direct metal laser sintering, same thing. You're shooting a laser into this powder and you're melting it into a solid. Put in a special sintering oven. There's actually one behind John's head, our Sinter 2. This is the Easy Bake oven for metal. Very easy to use a Markforged sintering oven. There you go. It's a beautiful looking machine. You slide your metal parts in there, these pre-metal parts. You close the door. You select your type of material. We do 17.4 stainless. We do let's see, I have the list right here. 17.4 copper, Inconel 625, H13 tool steel, A2 and D2 tool steels. We got some more coming out later. You pick that on your Easy Bake oven menu, and you close the door, and 20 hours later, plus or minus, you get an email saying your parts are done. You open it up, there are your metal parts. In that sintering oven, it goes through a very special temperature curve that causes this metal part to shrink and cook. As it shrinks, it distorts. This is process variation, right? In fact, right now, we as a society, civilization, are still learning about how this shrinking happens. It's hard to predict, it's hard to simulate. And so what we're doing with Blacksmith is we're actually learning about how all these parts are being sintered in parallel, how those parts are distorting, and actually having the software pre-predict those distortions, pre-distort your part so that when it goes to the sintering oven, it shrinks into exactly the right shape. This is something that, you know, humans could do, but it's really just a waste of your time, right? You want to go back to, like, you know, machining the next part, designing the next thing, solving the next problem, or, you know, hanging out outside, whatever it is you want to do, right? So this AI and this software, you know, solving a bunch of kind of problems right now that we don't want to have, but eventually solving a bunch of problems that we just have because this is the way we've been doing things, right? And as these hardware and software get smarter, it will complement and actually make people more productive, right? You can do two things instead of just doing one.
John, anything to add?
How do you add to that? No, I think that's awesome, and you know, we constantly look for areas of improvement. One of the speakers that we had with our leadership group was the women's soccer coach at University of North Carolina, where he talked about measuring everything. And you know, they measured how fast people were running in practice, how many goals they kicked, you know, everything about that and use that data to improve their soccer team players. And Mia Hamm is a graduate of University of North Carolina, and she talks about this process where you're taking all this data, using it to make yourself better. And I'm encouraged to hear that on a more of a scientific level, because it is complicated to try to figure out how metals are going to react in a sintering oven. And that problem needs to be solved. And really the only way to solve it is through an improvement of an algorithm, to make that more predictable.
Great. Well, we're almost up at the hour here. I just wanted to, kind of wrap up just with some final thoughts from both of you on a little bit about the partnership between Phillips and Markforged, and what you feel makes this a great partnership, how Phillips and Markforged complement each other, and what we're excited to accomplish together in the near future.
John?
So I enjoyed spending an hour earlier with David. What an insightful mind, and it's really neat to hear the story of Markforged and how it has grown. Enjoyed talking about the BattleBots and all, but really we spent a lot of time talking about where the marketplace is going and how we can complement each other. And we found a lot of similarities with how additive can complement machining. And Phillips has been in the machining business for a number of years, supporting our customers. We're really looking forward to bringing a technology that fits that job shop to our customer base to help them be more successful. And, I think we've been hesitant to get into any type of fused deposition modeling, because we sort of felt that it was something that, probably someone would have in their home and really wasn't industrial. When you come across the thinking about Markforged and the resiliency of the parts, the cloud-based networking, the thoughts that are going into this, it really fit the market and the customers that we currently have and support. So that's where we're very excited about. Obviously, the people at Markforged have been great, and we can't wait to see what's possible.
I'll add to what John said. Look, we make a tool, and that tool is going on some tool belts. Phillips has 60 years of experience and relationships helping customers of all types solve important mission critical manufacturing problems, right? They're deploying a number of different solutions, other tools that were added to their tool belts. And this is just one more, right? So we make this tool, we want to learn what problems it can help it solve. I said earlier that the best part of my job is seeing the insightful creativity that customers come up with. Phillips knows how people make things, right? They know how to help you make things better, right? And Markforged is a new tool on their tool belt to help everyone here solve more problems, right? And so I'm excited to see kind of how we can expand and change the way folks make things, help them make things faster, help them make things cheaper, improve pressures or other things on other machine shop. And so I'm, aside from hanging out with John before this, I'm stoked to see where this all goes. So.
Great. Well, thank you for your time, both of you, and the lively conversation. It's very informative. I've worked here for almost 4 years, and I still keep learning things every single time. So I hope our attendees also learned a lot and got inspired for some manufacturing creativity. So thank you again for joining us and for your time, John and David.
Thank you.
Thank you, everyone. Enjoy your Thursday.